Hi and welcome to the channel. I'm going to take you through two tests that I've done with my replication of the gap generator with no moving parts. So the first test, well, let's have a look at the setup first. All the tests are made, or both tests are made. Here, this is the input. I have my power supply at the end of these cables. This is the to from coil, and this is called the M2 here. It is the AC input, and we have M3, and this is the rectified path to the load. All right, so let's see. Test number one, it's with coil number one, and if you are very curious about what the coil number one is, you can see that in the video, the earlier video with the overview. I have two 500 watts halogen lamps in series, and that equals 16.7 ohms in total for the load. Here we can see my measurements and the picture from the oscilloscope. From the input, the DC input from the PSU, the power supply, and the oscilloscope is DC coupled. 64.77 watts input. The M2, this is the AC input to the coil, and you can see the oscilloscope picture here, and we have 37.18 watts. The cycle is 30 milliseconds on, 10 milliseconds off, and then it changes polarity with the relays, and it's 30 milliseconds on and 10 milliseconds off again. And these are the measurements from the output, and the DC output, or rather with the oscilloscope DC coupled, you have both AC and DC, and we get 32.81 watts here. The results from test number one is, as you can see here, 49% of unity, so it's rather bad actually. Only 50% of the input is going to the load, at least from my understanding, and you should know that I'm no engineer. I have actually, much of the things I've done with this replication is the very first time. I have never used an oscilloscope before, and I have had a lot of help from Art doing this, and of course I've studied myself as well. I'm not using the AC output to load when I'm calculating the unity measurements, and I was very surprised when I sent my CSV files from the oscilloscope to Art, and he answered me back that this was 279.38% over unity, and I don't know what I'm missing. And I mean, we had some faults with the CSV files and some hardship when it comes to isolate one cycle in the CSV files and so on. So this measurement, this percentage over unity from Art might be totally wrong. My test number 3 And test number 2 was just with the second coil, but with the lamps in series. And we already have that on the test number 1. And they are very similar, the coil number 1 and coil number 2. There's a little bit more wire on the second coil. But the halogen lamps are in parallel, and the total ohm is 4.3. And you can see the input, and because of the load being in parallel and the ohms so much lower, my power supply is able to push much more current into the system. So we have the 267.5 watts input, and you can see the oscilloscope picture as well. When it comes to the AC input to coil, we can see that these are all RMS values from the oscilloscope. So it's the VR portion of the oscilloscope down here on each and every measurement. So we have 85.63 watts AC input to the coil. And I must admit, I'm not really sure how to measure this, because I mean the coil also releases something. When you push current to it and you instantly switch it off, there's something going on. So this measurement might, maybe it should have been measured some way different than this. But you have the picture here, if you understand it any better than I do. Okay, and here we have the DC coupled and AC coupled output to the load. The results from test number 3 is even lower. We now end up with 25% of unity. That's like, it's really bad. And yeah, the interesting thing is that from Art's calculations, when he adds more and more load in parallel, he gets more and more over unity. And I will show you why I think that is. And I have, well, let's not get ahead of myself here. So, comments. Art doesn't take the input from the PSU or the battery into consideration. He only measures M2 as input and M3 as output. So let's look at the setup. So he looks at this here as input. That's his input in all the tests he's making. And this is the output in all his tests. So he totally disregards from this. And in my world, that doesn't really make sense. But again, I'm not an expert, and Art has done this for years and years and years. And he says that it's not really interesting to look at the input. It's not, yeah, because he just looks at the input to the coil and how much you can measure on the output. So if you have anything to say about that, please give me a comment. According to Art's way of measurement, I get the following results on the 2 above tests. So number 1, if I only measure M2 and M3, I get 88% of unity. In the test number 3, I get 229% of over unity. And that is because, let's go back here to the results. If I use this one here as an input, as the only input, and I use this one as the output, I mean, the numbers are incredible. Totally incredible. I get lots more out than I put in. But in my reality, this number is crucial. This number tells you how much you put into the system. But again, me and Art's opinions differ here. So, yes, now you know. So let's go back. And let's have a look at Art's test. This is one of his tests. He has them on his webpage. And we can see that he measures the volts in and the amps in. And these are to the coil. These are to the coil. We can see that he measures 48 volts at the power supply. But we don't know how many amps he's pushing into the system. We can see his AC volts out, AC amps out, DC volts out, and DC amps out. So he always measures with his instruments. He's got these digital clamps, you know, like the multimeter style. And he checks for both AC and DC. And I presume he's adding these up. So for example, here he gets 79.63 AC watts out and 491.69 DC watts out. And he adds them together. And this alone makes me think that he might be measuring energy twice in some way or another. And these, from my understanding, these amp clamps, they are made primarily to measure like 50 hertz, 60 hertz, thereabout, and not perhaps the frequency you get when you use, it seems here he uses 50 milliseconds on, 50 milliseconds off. And the same goes for the, yeah, he doesn't measure with an oscilloscope. Yes. A reason for Art to not measure the input is an experience he's had with the fuses not blowing even when he's pushing in more amps into the system than the fuse is rated for. And I made a test showing that a 6 amp fast-acting fuse with a cycle of 50 milliseconds on and 50 milliseconds off, then it blew at 6 amps. When I pushed 6 amps through it, it blew. When I used the cycle of 30 milliseconds on and 30 milliseconds off, or rather 3010. I believe it should be 3010. Anyway, the fuse blew at 9 amps. So there's a huge difference according to what frequency you use, what pulse frequency you use. So you can't really just go with a rating on the fuse as a reason to totally dismiss the power supply value to be non-valid. Yeah. So that's it. Yeah. I hope you enjoyed this, and I look forward to your comments. I have another thing that I'm interested in hearing your comments about, and that is I have seen some interesting videos on a channel that I will put in the comment or in the description area of this video. And from my understanding from his channel and the videos, the impedance of the coil is really important. If you have a high impedance coil, there's a chance to do some magic, but you really need to check that channel out. And please tell me if you think that it's a good idea to make a new coil with some much smaller wire to get the impedance up. Yes, so check the description box for that. All right, thank you.